Yeah, so Arush, I was telling you that we have now two possibilities. One is x equal to 1, other is x square plus x plus 1 equal to 0. Okay. So now we have to solve this x square plus x plus 1 equal to 0. Do you realize this is a quadratic equation? We can solve this using the
Yes.
formula method. तो यहाँ
Yeah.
पे a is 1, b is 1, c is 1. तो x is equal to minus b plus minus root b square minus 4ac upon 2a से solve करेंगे. So you tell me orally, just substitute everything orally and tell me what are we getting.
-1 plus minus root 3i by 2.
हाँ, तो रूट ऑफ -3 आएगा बेसिकली, विच इज गोइंग टू बी √3i. So -1 plus minus √3i upon 2. So there are two answers. एक -1 plus √3i upon 2 और एक -1 minus √3i upon 2. ठीक है, so these are the two values of x that we have. So the thing
Yeah.
is, Arush, these are the other two cube roots of unity, cube roots of 1. और ये कॉम्प्लेक्स नंबर्स है, तो इनको हम बोलते हैं, they are denoted by this symbol which looks like w, but it is, maybe you can say w in italic font. It's called omega. It's like again a Greek symbol, alpha, beta, gamma, delta, वैसे omega. And this
हाँ.
is actually omega square. यहाँ पे अब कुछ properties तुझे समझनी पड़ेगी. When you square this number using a plus b the whole square, you'll get this number. And if you square this
हाँ.
number using a minus b the whole square, then you will get this number. They are actually squares of one another.
Yes, sir.
ठीक है. One more thing which you have to note over here, ये x square plus x plus 1 equal to 0 जहां भी दिखेगा ना algebra में, that means इसके answers है omega omega square. In any
Yeah.
chapter in algebra, if you come across this equation x square plus x plus 1 equal to 0, you should know this, that it is going to be omega and omega square without solving it. Solving में time waste नहीं करेंगे वहां पर. We can directly say it is omega and omega square.
Yeah.
Are you following this?
Yes, sir.
चलो, so now let's note down two properties which we'll be using. देखो ये proof वैसे syllabus में नहीं है. Nobody is going to ask you this proof, but you should know it so that you know what are the values. और ये values भी learn नहीं करना है. We will hardly be using these values. Mainly there are two properties which we have. The first property is, see, omega is a cube root of unity, Arush, barabar. So is it safe to say cube root of 1 is omega?
Yeah.
And if you cube both sides, we get omega cube is equal to 1. So that is one property. Omega cube is equal to 1. Second property. Now we had that equation 1 plus x square plus, we had that equation x square plus x plus 1 equal to 0. Now Arush, we know that omega is the cube root of unity, right? So omega is the value of x. So can we say omega will satisfy this equation?
Yeah.
So basically we can now write 1 plus, I'm replacing x with omega. So we get 1 plus omega square is 0. ये प्रॉपर्टी हम यूज करने वाले हैं. Are you following this?
Yes.
And now the next thing that you have to understand is इसके दो versions भी है. In fact 3 versions है जो हम यूज करेंगे. So if I ask you what is 1 plus omega, so we basically take omega square on the other side, it will become minus omega square.
Yeah.
If I ask you what is 1 plus omega square, so that will be minus omega, and omega plus omega square will be minus 1.
Yeah.
Right, this Arush. So the next concept, Arush, is again a very important one, modulus of complex numbers. तो ये हम थोड़ा ज्योमेट्रिकल एक्सप्लेनेशन भी देता हूँ मैं इसका, और फॉर्मूला भी बताता हूँ. ठीक है, विल डिस्कस बोथ. इफ z इज a plus ib, Arush, this is the standard form. मॉड्यूलस ऑफ z का सिंबल होता है mod of z, जो अपना अलजेब्रा का मॉड्यूलस है, एंड द फॉर्मूला इज स्क्वायर रूट ऑफ a square plus b square. So you basically have to take the real part, imaginary part, square and add. For example, if we have a complex number -3 plus 2i, tell me the modulus of this complex number.
-3 square plus 2 square.
So that's going to be root of 9 plus 4, which is 13.
9 plus. Yeah.
Okay, so that is modulus of complex numbers. Now the next thing that we have is argument of complex numbers. But before we take that, we need to revise 2-3 concepts of trigo which you already know. ये थोड़ा हम देख लेते हैं. सो इन कॉम्प्लेक्स नंबर्स ये जो अपना नॉर्मल एक्स एक्सिस वाई एक्सिस होता है, एक्स एक्सिस को हम बोलते हैं रियल एक्सिस, वाई एक्सिस इज कॉल्ड इमेजिनरी एक्सिस, एंड कॉम्प्लेक्स नंबर का जो ग्राफ है ना, दैट इज कॉल्ड आर्गेंड प्लेन. So argand plane is
Hmm.
basically x axis is real axis, vertical is y axis, which is imaginary axis. The quadrants are same: first quadrant, second, third, and fourth. Now, in trigonometry, we have studied that 180 degree represents pi,
Yeah.
90 represents pi by 2,
Pi
360
by 2.
represents 2 pi. ये पता है हमें, ये
Pi.
देखा हुआ है हमने, बराबर. तो
हाँ.
90 को मैं मार्क कर रहा हूँ pi by 2, 180 को pi, and 360 is going to be 2 pi. Now, do you know this rule that if one angle is in first quadrant, it is theta. Second quadrant
Hmm.
में अगर होगा तो वो pi से थोड़ा छोटा होगा. It will be lesser than pi, so it will be pi minus theta.
Yeah.
In third quadrant, it will be more than pi, so it will be pi
Hmm.
plus theta.
Pi.
And in fourth quadrant, it will be lesser than 2 pi, lesser than 360, so 2 pi minus theta. This is how we
Yeah.
represent angles in trigonometry. Are you writing this, or shall we proceed and see how are we going to use it?
Yeah. So we can proceed.
Chalo. So now one more thing. Inverse trigonometry का थोड़ा basic concept. So you already know tan 30 is 1 by root 3. So if I ask you what is tan inverse of 1 by root 3, then you will tell me 30
30.
degree. Right?
हाँ.
This is how inverse
Yeah.
trigonometry works. Tan 45 we know is 1. So tan inverse of 1 is going to be 45. Tan
45.
60 we know is going to be root 3. So tan inverse of root 3 is going to be 60.
60.
ठीक है, और इसको पाई में कन्वर्ट कर सकते हैं हम एज पर द रिक्वायरमेंट ऑफ
हाँ.
द क्वेश्चन. सो नाउ लेट्स टेक आर्गुमेंट ऑफ कॉम्प्लेक्स नंबर्स. अब समझ जाएगा आर्गुमेंट. सो इफ वी हैव z is equal to a plus ib, if this is the standard form of a complex number, argument of z, Arush, is denoted by arg of z, argument of z, and the formula is tan inverse of d by a.
Hmm.
That is the formula, tan inverse of d by a. So for example, if we have a complex number 3 minus 3i, you have to tell me, Arish, what will be the answer? What will be the argument of z?
Tan inverse of minus 3 by 3.
Tan inverse of minus 3 by 3. And what is that?
45.
45? That's wrong. That's absolutely incorrect. Because here, Arush, you have to now decide the quadrant. 3 minus 3i कौन से quadrant में होगा, Arush? The point 3 minus 3i, do you realize, will be in the fourth quadrant.
Hmm.
And in fourth quadrant, how do we represent the angle, Arush?
-1.
Fourth
अच्छा
quadrant
plus.
is 2 pi minus theta.
2 pi minus theta.
So over
हाँ.
here, answer is not 45. It is actually 360 minus 45. So it is 2 pi minus 45. Minus pi by
Yes.
4. Take LCM, you will get 7 pi by 4. Are you understanding this, Arush? Quadrant बहुत important हो जाता है when we talk about argument.
हाँ sir.
Did you understand this?
Yes sir.
Like this.
Yeah.
So now coming to the geometrical interpretation about modulus and argument. See, modulus is actually the distance of a complex number z from origin, Arush. If we have a
Hmm.
complex number z, अब यहाँ पे मैं एग्जांपल ले रहा हूँ, ये 3 plus 3i, ठीक है. Now if I join this z to origin, Arush, तो ये है modulus z. ये जो distance है ना, that is modulus z. Let's take one example. If I say z is x plus iy, so can you tell me what will be this distance? ये जो vertical distance है, the distance from x axis, the vertical distance of the point, what will this be?
Y.
Y. So that distance is y. So this is y. And what about the horizontal distance? ये जो horizontal distance है,
X.
तो इसको x बोल सकते हैं. So Arush, what will be the formula for mod z? Can you use Pythagoras and tell me the formula? यहाँ पे Pythagoras use कर,
Root
what
of
will we
x
get?
square plus y square.
Exactly, and that's what we have studied, right? Modulus z square is x square plus y
Hmm.
square आएगा, which means mod of
Yeah.
z is root of x square plus y square. That is the formula for modulus. Okay,
Yes, sir.
coming to argument. Argument is basically, see, if you look at this line joining the point to the origin, that line makes some angle with the positive x-axis.
Hmm.
That is argument. अब जैसे इसको अगर हम y और इसको x ले रहे हैं, and this is theta. What is tan theta from here, Arush?
Y by X.
So if tan theta is y by x, can we say theta is tan inverse y by x?
Yes, sir.
That's exactly what we have written. So geometrically, this is modulus and argument. Chalo, so Arush will take the properties of modulus and argument of complex numbers. The first property, for a complex number z, the modulus of z and modulus of its conjugate is same. Because see, conjugate में सिर्फ sign change होता है Arush. But when we take modulus, we are anyway squaring the coefficients, right? So it
Ah,
doesn't matter. So it just
yeah,
remains the same. Next property is
yeah.
very important property. It will be used in many sums. So z multiplied with z bar. When we multiply z with z bar, that is actually modulus z ka square. Let us see. Let us verify this with one example. So if we have z as, let's say, 3 minus 4i, so z bar will be 3 plus 4i. Now when we multiply z with z bar, ठीक है, ये orally करते हैं. Let's multiply these numbers. Do you realize this is one of the expansion formulas? When you multiply z with z bar, which expansion formula will this be?
Oh, wait, sorry, sir. I was on. Yeah, A square minus B square.
तो a square minus b square से ये होगा 9 minus 16 I square,
16I square.
which is
So
9 plus
25.
16, which is 25. एंड मॉड्यूलस z का स्क्वायर जो होगा, सी मॉड्यूलस z का फॉर्मूला होता है रूट ऑफ x स्क्वायर प्लस वाई
हाँ,
स्क्वायर.
सर
बट
एक
डू यू
सेकंड
रियलाइज?
तो एक सेकंड.
हाँ. यस आरुष, आर देयर?
हाँ सर.
सो व्हाट आई वाज
हाँ.
सेइंग इज मॉड्यूलस z का जो स्क्वायर है दैट इज रूट ऑफ x स्क्वायर प्लस y स्क्वायर, और उसको भी स्क्वायर करना है. तो रूट एंड स्क्वायर विल गो अवे एंड वी हैव 3 स्क्वायर प्लस माइनस 4 का स्क्वायर, व्हिच इज 9 प्लस 16, व्हिच इज
या
25. सो दिस इज द फॉर्मूला.
या
ठीक है. नेक्स्ट,
हाँ सर.
मॉड्यूलस ऑफ z1 z2 मल्टीप्लाई अगर होगा तो उसको हम ऐसे स्प्लिट कर सकते हैं, मॉड्यूलस ऑफ z1 इनटू मॉड्यूलस ऑफ z2. एंड द सेम कैन बी डन फॉर डिवीजन. अगर ऐसा दो डिवाइड हो रहा है तो उसको हम ऐसे स्प्लिट कर सकते हैं, मॉड्यूलस ऑफ z1 अपॉन मॉड्यूलस ऑफ z2.
या
राइट दिस. चलो, नाउ लेट्स टेक द प्रॉपर्टीज ऑफ आर्ग्यूमेंट. देखो, आर्ग्यूमेंट में if we have argument of z1 into z2, ठीक है, multiplication of two complex numbers, then we can split this as argument of z1 plus argument of z2 plus 2k pi, where k is either 0 or -1 or 1. और ये हम सम टू सम वेरी करेगा, ये हम डिसाइड करेंगे सम्स में कि k का वैल्यू क्या होना चाहिए. द टारगेट इज दैट सी आर्ग्यूमेंट होता है tan इनवर्स आर्स, सो द आंसर शुड लाई इन द रेंज ऑफ tan इनवर्स. दैट इज द टारगेट. So you have to take the value of k accordingly that it lies in the range of tan inverse. तो अगर डिवीजन में हमने ऐड किया आरुष, तो तू गैस कर कि मल्टीप्लिकेशन में क्या होना चाहिए.
मल्टीप्लिकेशन में ऐड किया, डिवीजन में
सॉरी,
सबट्रैक्ट.
मल्टीप्लिकेशन में ऐड किया, सॉरी, या सो डिवीजन विल बी
हाँ.
subtract, yeah,
सब.
that is subtract. And again plus 2k pi where k will be either 0 or 1 or -1, वो हम सम में डिसाइड करेंगे. नेक्स्ट इज आर्ग्यूमेंट ऑफ z बार जो होता है दैट विल बी नेगेटिव ऑफ आर्ग्यूमेंट ऑफ z. क्योंकि उसमें सिर्फ इमेजिनरी टर्म का साइन चेंज हो रहा है, सो द क्वाड्रेंट चेंजेस, सो इट्स जस्ट गोइंग टू बी
Hmm.
नेगेटिव ऑफ आर्गुमेंट ऑफ सेट.
Yes.
Yeah. Have you written this? If you have, then we can
Yeah.
just start the sums.
Yeah.
तो चलो स्टार्ट करते हैं. So these are some basic sums. We have to first find the least positive value of n for which 1 plus I upon 1 minus I raised to n is equal to 1. So tell me, Arush, what do you think we should do? We have 1 plus I upon 1 minus I.
Multiply, divide by 1. So,
Correct. We'll multiply divide by the conjugate. So we'll
yes.
basically
One.
multiply divide by 1 plus I. So chalo start karo.
Yeah.
You do this and tell me what are you getting.
Ah,
Oh, this is minus.
sir, I'll just.
So Arush, in the numerator, are you using a plus b the whole square formula? A square
Yeah.
plus b square plus 2ab. And denominator is a plus b into a minus b, so it's a square minus b square.
Yes.
So check this. Are you getting 1 minus 1 plus 2i upon 1 minus of minus 1? So this is basically 2i upon 1 plus 1 हो जाएगा 2. So Arush, you should get I to the power n is equal to 1. Check this.
So N will be ah,
N का ऐसा least positive value कौन सा होगा Arush? For which
4, 4.
4. So n is 4. That's the answer.
Hmm.
Done? Shall we take the next one?
Yeah.
Sure. Second वाला. Summation n is equal to 1 to 5 I raised to n plus I raised to n plus 2. Tell me Arush, how will you solve this? ये एक्चुअली बहुत ही इजी है और ओरली हो सकता है. अगर तू थोड़ा स्मार्टली करेगा ना, बहुत इजीली ओरली हो जाएगा ये. You don't need to substitute the value of n and then have 10 terms और उसको solve करो, करना ही नहीं है. बहुत easily orally हो सकता है ये. Just think about this a bit.
Hmm. Makes sense. So,
I raised to n plus I raised to n plus 2. So is it safe to say, Arush, that this is
if,
addition of alternate powers of I? It's like I
yeah.
and I cube is added,
Yeah.
I square and
So
I raised to
0 हो
4 is
जाएगा sir.
0 हो रहा है. Exactly. Answer 0 आएगा. That's the answer.
Enough. Yeah.
Yeah. Third sum is interesting. Read the question. ये अब थोड़ा मेहनत का काम है. So what's coming in your mind, Arush? What should we do? They have asked us to find the value of x cube plus 7x square minus x plus 16 when x is equal to 1 plus 2i. What do you think we should do?
Solve x cube plus 7x square minus x 16. Then
What do you mean by
substitute.
solve? अच्छा, substitute value of x. ऐसा बोल रहा है तू 1 plus 2i the whole cube plus 7 into 1 plus 2i the whole square minus 1 plus 2i plus 16. Is that what you're saying?
पहले उसको नहीं, उससे पहले x cube वाले उसको पूरा solve
उसको solve कैसे करेगा? उसको solve नहीं कर सकता.
कर सकते हैं, भूल गया कैसे.
नहीं नहीं, क्वाड्रेटिक नहीं है ना. हाउ विल सॉल्व दैट? मतलब
हाँ,
क्यूबिक को भी कर सकता है सॉल्व,
कर
बट
सकते हैं.
डोंट डू दैट. अरे उससे होगा क्या? उससे तो तुझे 3 ब्रैकेट्स मिलेंगे ना. हाउ डज
हाँ,
दैट हेल्प? दैट विल नॉट हेल्प यू. हाउ डज दैट
तो
हेल्प
फिर
यू?
डायरेक्टली सब्स्टिट्यूट कर.
डायरेक्टली सब्स्टिट्यूट इज अ नाइटमेयर. टू मच वर्क, टू मच. So there is a smart method for this. That smart method is you start with the value of x. We have x is equal to 1 plus 2i. And the first thing that we will do is we will remove I from here. We will eliminate I from here. Now, how do we eliminate I? So, do you realize if we somehow create I square,
Hmm.
I square minus 1 होता है,
हाँ,
so I will be eliminated if we create
hmm.
I square. Now, how can we create I square?
Multiply, divide.
नहीं नहीं ऐसे थोड़ी, तो
Multiply
नीचे
both
I आ
the
जाएगा.
sides.
How does that help?
अरे मतलब multiply both the.
नहीं 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 मल्टीप्लाई थोड़ी, वो तो फिर लेफ्ट में I क्रिएट हो जाएगा. इवन दैट डजंट हेल्प. So we will square both sides, Arush,
हाँ.
because we
Hmm.
want square I square. But then the
Yes.
challenge is you cannot square at this step, क्योंकि अगर इस स्टेप में स्क्वायर किया तो राइट में a प्लस बी द होल स्क्वायर आएगा, तो उसमें
Hmm.
बीच में 2ab वाला टर्म आएगा विच विल बी 4i.
One को
That
left
doesn't
side
help.
ले जाओ.
Exactly, we'll take one on the left. Now square both sides.
Yes.
So this is x square minus
Square
2x plus
minus
1
2x
equal to
plus 1.
4i square.
4i square.
Now 4i square is minus 4. Minus 4 को left में लो, so this will be x square minus 2x plus 5. Check this. Are you following
Plus
this?
5. Yes.
And now, Arush, you have to divide the given polynomial x cube minus 7x square minus x plus 16. You have to divide this by x square minus 2x plus 5. Long division method बचपन में सीखा होगा.
हाँ सर.
Do you remember it?
Hmm.
तो करो, चलो डिवाइड करो. टेल मी द quotient and the remainder.
Yes.
So Arush, once the division is done, do you remember that formula? Dividend is equal to divisor into quotient plus remainder.
Divisor into quotient. Yeah.
तो यहाँ पे डिविडेंड जो है एक्स क्यूब माइनस
X
सेवन एक्स
cube
स्क्वायर माइनस एक्स प्लस 16 इज इक्वल टू डिवाइजर इज एक्स स्क्वायर माइनस 2x प्लस 5 इंटू क्वोशंट इज x माइनस 5 प्लस रिमाइंडर इज माइनस 16x प्लस 41.
yeah,
Now Arush, what do we know about x square minus 2x plus 5?
that's equal to 0.
That's equal to 0. तो ये पूरा तो 0 हो गया. So do
पूरा
you realize
टर्म
the
हो
final
जाएगा.
answer is minus 16x plus 41?
Yes.
Now you substitute x. Now you substitute x is 1 plus 2i and solve this. So this will be minus 16 plus, sorry, plus name, minus 32i plus
Minus 32i.
41. So 41 minus 16 is 25
25
minus 32i. That will
plus
be the
2i.
final answer. Done. That's the
हाँ
answer.
सर. Yes.
ठीक है, चल आगे बढ़ता है.
Hmm. एक सर.
Writing that. Right. Done.
हाँ सर.
Yeah, we should take the fourth one, which is a very interesting question. बहुत easily हो जाएगा ये. So I'll tell you what is to be done. See, a plus ib is equal to c plus I upon c minus I. That is the equation. A plus,
Hmm.
नहीं ये c plus 1 है या I है, चेक कर बुक में, यहाँ पे क्लियर नहीं
C
है.
plus I है. C plus.
हाँ, और नीचे c minus I है, करेक्ट.
Hmm.
And we have to prove this, Arish. A square plus b square is equal to 1. अब ये है ना एक
Yeah.
observation है. To make one very important observation over here, because this observation is going to be used in many questions. The observation which you have to make is, do you observe a plus ib, and this a square plus b square is actually modulus of that.
Yes.
So in those sums where in the given part we have a complex number and कुछ prove करने बोला है in which one part is modulus, what we will do is we will simply take modulus on both sides.
Module. So,
Just take modulus on both sides. So it's like mod of a plus ib, एंड यहाँ पे हम मॉड को स्प्लिट कर सकते हैं, तो सी प्लस आई एंड दिस इज गोइंग टू बी मॉड ऑफ सी माइनस आई.
Hmm.
See, this will be root of a square plus b square.
Ah,
This will be root of c square plus 1.
C square plus
This will be root of c square plus 1. Now square both
I.
sides, we'll get a square plus b square. And do you realize RHS is actually 1? क्योंकि ऊपर नीचे same है.
Hmm. Yes.
Oh, yeah, done. First part is done. ठीक है, क्लियर है ये.
हाँ.
जो सेकंड पार्ट है ना, बी अपॉन ए, इसके लिए तो मेहनत करना पड़ेगा, इसका तो कोई ऑप्शन है नहीं अपने पास. इन दिस यू विल हैव टू
एक
गो
सेकंड.
विद द लेंदी प्रोसीजर.
हाँ.
So for the second part, you have to multiply these complex numbers. What I mean is, we have a plus ib is equal to c plus I upon c minus I. So Arush will have to cross multiply this, a plus ib into c minus I. Shall I
Hmm.
expand the brackets on the left and tell me what are you getting?
AC minus BI plus
ac
IB
minus ac minus ai होगा.
AI. हाँ सर
ac
वही.
minus ai plus bci
Plus I BCI
minus bi
plus
square
minus I square.
is equal to
Yeah.
c plus I. Okay, so now we have AC minus AI plus BCI, and this is plus B, which is equal to C
Yes.
plus I. So AC plus B को एक ग्रुप बना देते हैं, AC plus B, and I वाले टर्म्स को कॉमन लेके we have BC minus A into I, which is equal to C plus I. Are you following this, Arush?
Hmm.
Oh, sorry, I दो बार लिख दिया
सर
मैंने.
दो बार I लिख दिया.
Yeah. So now you just have to compare LHS and RHS. So this is the real part. Real part will be compared with real part. So we get
Yes.
AC plus B is equal to C.
Hmm.
ठीक है? And we have the second one, which is
BC minus
BC
C is
minus
equal
A
to
is
1.
equal to 1.
हाँ.